Live streaming is on.
Okay, so here we go. Um, have you opened to it?
Yes.
All right, so I'm also going to be sharing my screen.
Okay.
Can you see my screen?
Mm-hmm.
Okay, that's good. So you're going to be reading.
Okay. Programming foundations through Rust. Session 1. What is programming? Language agnostic foundations. This session is about thinking like a programmer, not writing code yet, no syntax, no Rust rules, just mental models.
Yeah.
It says, what is a program? A program
Please,
is a set of
please hold on like that.
instructions. All right.
All right, let's do it. Let's write down.
All right.
Yeah. Yeah. So as you're saying, this session is about thinking like a programmer, right? Not writing code yet. So we're not focused on a specific syntax. No Rust rules yet. Just mental models. So let's look at the overview of the program. Go ahead.
A program is a set of instructions written for a computer to follow, just like a recipe tells a cook what to do. Driving directions tell a driver where to go. Score a choir score tells singers what to sing.
Mm-hmm.
A
So a
program
program
tells
tells
a computer do this, then do this, then do this.
exactly. So with a program, yeah,
It's the same like an algorithm.
yes. So you're just telling the computer what to do, giving the computer instructions on how to perform a specific task for you. You get it?
Oh, it's okay.
Yeah. So you can see here that we say the computer does not think. It only does or it only follows instructions exactly as written. Yeah, on its own, it's probably it's dumb. It's just like any box out there. But it needs what instructions in order to know what to do and how to do it. Is that clear?
Correct.
Okay. Yeah, continue.
What is input? Input is data given to a program. Examples: typing your name into a form, clicking a button, reading a file, sensor data from a device.
Yes. So what is input? So um in order to get a specific output from the computer, most of the time the computer needs some input. So what do we mean by input? Input is the data that you give to your program. So that can come in several ways, many different ways. For example, if you when you want to log into ISC, then what do? You need to give it your ID and your password, right?
Mm-hmm.
Yeah, that's inputs that you're giving. And that input, based on the inputs, a specific some processes are going to run, and based on that input, they're going to give you a specific output. So if you give the wrong credentials, then you don't expect to log into your account. Also, when you click a button, you're saying something, right? You're giving an input. For example, if you fill in your ID and and your password, and you don't click log in, nothing is going to happen, right? Yes. So you need, when you click on that button, some message is being sent to the program or to the computer that something like maybe based on that button which you have clicked, this is what you want. Also, input can come from a file. So within your program, you can be reading a file to get your input. Also, input can come from what? Sensor data. For example, when you want to, let's say you want to, let's say you're using biometrics on your phone and you want to use your fingerprint to unlock your phone. That's data that you're giving your phone. That's input they're giving your phone, and based on that, it's going to give you a specific output. Is that clear?
Yes, sir.
Yeah. So in conclusion, think of input as what the program receives. Are we there?
Yes.
Okay. Okay. An example. So if a calculator app asks for two numbers, those two numbers are what? Are the inputs. And we know what input devices are, right? Give me examples of input devices you know.
Keyboard.
Yes.
Uh, your keyboard, is
Even your mouse.
your mouse, yeah, your mouse. Yeah.
Yes. So it's that, yeah, those are examples of input devices, which means they are used to give input to the computer or to your program. Are we there?
Yes, sir.
Yeah. Okay, now let's go to output. What's output?
Output is the result produced by a program, same as the output devices. For
Yes, so the
example,
output devices help show us the result, right, of our program. Yes. So you have examples here. You see a displaying text on the screen. So like now I'm reading from my screen, right? That's an output that I've gotten from this ISC Learn platform. Also, playing is sound. When you're listening to music, that's the output from a specific application or software, right?
yeah, or like the like if I can hear you now, it's output, and you can
Yes,
hear me.
exactly. Yes, that's output. Printing a receipt, that's output. Saving a file, that's output. So think of output as what? What the program produces.
All right.
So now there's a specific model which um programs usually follow. You see, this is a model. We have input, processing, and then output. So in summary, you can see the IPO model. So this is the most important mental model that you can have. So for example, let's say an ATM machine. You see we can break it down into what? Input, processing, and output. Inputs here, name the inputs here.
You put in your pin. You input the withdrawal amount,
Exactly. So
and
I think
then
you can even name more, right?
yeah,
In some ATM machine, they even ask for more. But let's say for this case, we just have to put in our PIN and the withdrawal amount. And what happens? The process. So a process has to occur before you get your output. So that processing step, that's where you do what you check the balance of the person. Based on their balance, you know whether you should withdraw the money or not, right?
yeah, exactly.
Yes, so that's where now we come now to have our output, which is the cash plus the receipt. You get it, right?
Yes.
Okay. Also, when talking about the calculator, what can be an input for a calculator?
2 plus 3, the process is the addition or the subtraction. If it was 2 minus 3, then
Yes,
it will be the expected result.
exactly. That's very true. So it's that with every program that you're writing, you can um you can always distinguish these three different parts. What's the input of my program, or what are the inputs of my program? What are the processes involved in this my program? And what is the desired output? You get it? Yeah, so that's it. So right now we are getting to the part where that's mostly what you're going to do. Like when you're drafting your algorithm, you should be thinking, what's the input, or what are the inputs of this my algorithm? What are the processes that are going to happen, and then what is the output?
Okay.
Because recall from our algorithm, we can move straight to our program, right? Okay, let's continue. So this is programming in its purest form. You get it? Having the input, processing, and output. That's programming in its purest form, like the most basic form of programming should have those three steps. Okay, so here we have instructions execute top to bottom. So I think you already noticed this right with Bash, that your program, or the instructions that you give, that you wrote down, they will execute from the beginning, or from the first instruction to the end, line after the other. Yes. So just you can start reading from here.
Programs run line by line from top to bottom. Computers do not guess, think, skip lines, understand intentions. They follow order. Example, conceptually, step 1, open fridge. Step 2, take milk. Step 3, pour into a cup.
Yes. So that's just it. You see, computers do not guess. They cannot guess. They cannot skip lines, and they don't understand intentions. As such, it means you need to write down, or you need to explain everything detailedly. You get it? Yeah. So we have, okay, this a conceptual example here. So step one, open fridge. Step two, take milk. Step three, pour into cup. So if let's say if you're directing a human being, you just be like, go and take the milk and pour into a cup. The person will know where to go to, right? But for the computer, you need to tell it where is that milk and all of that. Yeah, you need to list all the steps, and it's going to follow those steps from step one, go to step two, go to step three. So if you reverse the steps, it's going to fail. So order matters. So it won't say, it would, like we said, the computer does not guess. It will not guess that, oh, maybe there's an error in this thing, or maybe there's an issue here. No. So for example, in this one, if let's say we put step two first, and then step one should be the last. So you see, take milk, pour into cup, then open fridge. It will not make sense. Okay. So now let's move on to logic. What is logic?
See, logic is the decision-making structure of a program.
Yes.
Example, if it's raining, take umbrella. If balance is less than withdrawal, reject transaction.
Yes.
If password is correct, proceed with allow login.
Yes. So that's it. So you see so yeah, we're trying to say everything or your program that you write most at times or will mostly have what logic involved in it.
Mm-hmm.
I'm sure you have seen that already, right? There's a lot of logic in what we are doing.
Exactly.
Yeah, because at the end of the day, you are thinking for the computer. So you need to
Mm-hmm.
explain everything down detailedly. So if it's, for example, if it's raining, take umbrella. That's logic. You give it the inputs, maybe rain, and based on it, it knows what to do. If balance is less than withdrawal, do something. So let's say, for example, in this second line, what's the input here?
The amount that you input to withdraw.
So in this case, our input is the amount, and that amount. So first of all, let's see. Let me ask it this way: what do we need to know in order to actually come out? In order for this logic, this particular line, for it to be successful, what do we need to know?
The amount of money that you have in your account should be lesser than the amount you want to withdraw. Should not be lesser than the amount you want to withdraw. Because,
Yes.
for example, if you have
So
10,000 and you want to withdraw 15,000, it will reject the transaction.
okay. So in this line, what we can say is our input or what we need to know for this particular logic case is what we need to know the balance, right? We need to
And the
know
balance is
what
the
the
which is
person wants to
account.
withdraw. Come again.
Yeah, I was just trying to add more like.
Yes, so that's it. So we need to know the balance and we need to know how much the person wants to withdraw for us to even be able to do this calculation, right?
Mm-hmm.
Yeah. It's the same way with this one too. What's the input? We need to be able to know how to check if it's raining, right?
Mm-hmm.
Are we there?
Yeah.
Yeah. So we need to know how to check if it's raining before we can even be able to predict whether I should take an umbrella or not. In this line, our inputs are the balance. We need to get the balance. This one we're not getting from the person, right? We're the ones checking the person's balance based on their account number. And then this withdrawal, the person who is supposed to give us how much you want to withdraw,
Mm-hmm.
right? And then what's our output in this case?
The output should be the the message which will display that they don't have enough money in the balance on the screen or
Exactly.
what.
Yes, yes. So that's the output. Okay, let's come down to this one. What's our inputs?
If password is correct, allow login. The correct digits of the password,
Come again.
what they use, what the person will input, what the person
Yes.
will type based of the password should be
Yes.
the
So
input.
yeah, so the input is the password. So it can be anything. So whatever the person types, that's the password that the person is typing. And now we have to check our so so you see all of these cases, this logic here, these are the processing, right? This is the processing stage. All of this logic that we're putting,
Yeah.
this is the processing stage. That's why I say I'm not asking about the processing. I'm just asking the input and the output. So based on that
Mm-hmm.
input, which is the password, we have to do this logic. And based on this logic or based on this process, what's our output?
The message which shows that the person has successfully logged in.
Exactly. So our output is you logging the person into their accounts. Okay. So
That's
continue
only
with
if
the
the password was correct.
yeah, that's only if the password was correct. Very true. Which means in this case, or in most of these cases, actually, you have like two different feedback, right? In case it's not, you do this other one instead.
Mm-hmm.
Yes. Okay. Let's continue from here.
Logic is about conditions, true or false, and the third one, decisions.
Yes.
Programming is structured logic.
Yes, programming is structured logic. So one thing to the other, like everything is structured. You can look at it and like, okay, this space, yeah, you're looking at conditions. Yeah, you're checking if this is true, then do this. If this is false, then no. Yes, you are doing some more decision making based on a specific scenario. Everything is structured. You leave one and go to the other, like we said, it's line by line. A computer cannot guess, so you need to simplify it right down to the smallest terms.
Okay.
All right. So why writing programs or why dealing with programs, we deal a lot with memory. So let's see what's memory.
Memory is where a computer stores information temporarily while running. Think of memory like a notebook, a shelf, a label box. When a program runs, data is stored in memory. Calculations happen in memory. Results are stored in memory. Later, we'll store values in memory using variables.
Yes. So that's memory. You see that memory is where a computer stores information temporarily. So take note of it, the temporarily. And while running. So while running,
Mhm.
so it only stores that information when the computer is on. Once the computer is switched off, that's all. Everything in the memory disappears. Are we there?
Yeah.
So think
But
of memory. Yes.
we heard about, but there's also permanent storage, no?
Yes, there is. There's permanent storage.
Okay.
Yeah, which comes in two categories, right? Our hard disk drive and our solid state drive.
Computer stores
But in this
information.
case, we're talking about the primary memory or the random access memory of your computer.
Okay.
Is that clear?
Mm-hmm.
Okay. All right. So like yeah, I mean that's clear because information is stored there. And information that's stored there is the information that is being used at that particular time by the CPU. So we see that what when a program runs, what happens? Data has to be stored in memory. For example, I said that what a program has things like what inputs. So those inputs need to be stored somewhere. Is that clear?
Mm-hmm.
Those inputs need to be stored somewhere. It's not as if let's say um you give a computer data and the data will just be hanging. No, the computer has to store that data somewhere so it can use it in there while running the program. Then calculations happen in memory too. When while running a specific process, what happens? The computer has to do calculations. So let's say the result of a specific calculation has to be stored in memory.
Mm-hmm.
Yeah, we see results are stored in memory. Also, even our instructions that we have in our program, they too have to be stored in memory.
Okay.
So later, like while writing programs, we're going to see how we use memory to store variables,
But okay.
or we're going to store values in memory using variables. We're going to see what variables are all about. So now let's go to this one.
A compiler. What is a compiler? Some languages are compiled. A compiler translates human readable code into machine code binary. Humans write print ln hello. The
So we can
computer
say print
understands.
line. So you can call it print line. Hello.
Okay. The computer understands binary.
Exactly. So you see, the compiler stands like what? A translator between between our code and the computer, or between us and the computer, such that we can write in a way which we understand. You get it?
Mm-hmm.
And then the compiler now translate that to a way which the computer will understand, which is binary. So we call everything that I give a computer, the computer can only recognize that thing if it's transformed to binary. Our images that we are seeing, videos that we are seeing, games that we are playing, everything the computer is seeing only ones and zeros. We are the ones who are seeing it. We are the ones who are even
So,
interpreting the colors like this color, and this, all of the rest.
so a compiler is like the medium where uh, the information that we have given to the computer is transmitted to the is being made for the computer to understand.
Yes.
Okay.
Yeah. So that's it. So that tells you that what most of these programming languages that we are using, underneath them or at the back, they all have something that has to help translate our code to binary. Is that clear?
Mm-hmm.
And that something most of the times is the compiler. So I said most of the
So,
times because there's also
so
another thing.
can we say that a compiler is like a software? Is it like a
Yes,
system on its own?
yes, it's also a system on its own. It's also a
All right.
software. Like you also use programs to write it. That's the funniest thing. So it's also a
Oh,
program.
all right.
Yeah. So it's also because at the end, like we said, the computer is dumb, right? It doesn't know anything. Which
Mm,
also tells you that for it to even know, for it to even for the compiler to even run, which because remember it's the computer that is running the compiler too, which means the compiler too is just instructions telling the computer what to do to be able to change your code to a language which the computer understands.
all right.
You get it? Yeah. Which means that people out there to build compilers.
All right.
Yeah. Okay. Let's see the next one. So, you see that a compiler converts between the two. Yeah. So it converts between human readable language to the computer readable language.
So
Okay.
when the computer understands it, it transmits the information to the compiler, and the compiler now sends it us back now to us.
No. It's the compiler is just one way, like from the human to from the human language to the computer language. When it translates it to the computer language now, before the computer now will run the code and give us what we are expecting, our output.
Okay.
Yes.
Because a little bit above, you said is a medium between the two, something like that. So I was confused. Like,
Yes. It's the
if
medium between the
it,
two. It
if
takes
it's a
from our
medium between,
end and gives to the computer.
And when the computer processes it, what now carries it now to us? Is it not still a compiler?
No, that's what we're talking about. What output devices like our
Okay.
screen, our speaker, all of those things.
All right. All right.
Yes. Okay. Now let's continue from here.
What happens when code runs? High level overview. Number one, you write source code followed by compiler checks for mistakes. The compiler then translates code into machine language. The computer executes it and output is produced.
Yes.
Important idea: code does not directly run, it must be translated first in compiled languages.
Yes. So that's it. So you see that um like this is a high level overview. So like this is a summary. I want to summarize everything because it's obviously a long process. Like it takes time too. Just that it's done very fast since the computer that does it. But even we summarize everything, this is what everything can be summarized into 5 steps. So first of all, you the human writes your code. You write your code. Then
Which is
now
the all right, all right.
yeah, yes, this code now, remember the code is in your language, right, which you understand, a specific programming language like Bash.
Okay.
Yes. Then now after that, a compiler now will take that code, check mistakes first. First of all, checks if there are any mistakes in that your code. That's why when you run something, you notice that when we run our Bash programming language, what happens? We see errors at times.
Mm-hmm.
Yes. So it checks for mistakes first. If there are any mistakes, it tells you. If there are no mistakes, before it goes now to step three, where it starts
Compile
translating and
this into machine language.
yes, exactly. Then once it's in the machine language, which means at this point in time, this after step three, the computer should be able to understand what you have written. So it can now do what? Execute your code or your program. So
And output now is produced.
yes, yes, and an output now is going to be produced. So execution is like it now doing what you want it to do or what you have written, what your instructions say. Okay. So we see that we are in compiled languages. Why? Because there are also some languages which are not actually compiled. They instead have what a different step which they follow, not compilation.
All right.
You get it? Yeah. I've sent videos on this on the resources channel in Discord, so you can go and also check.
Okay.
Yeah. So now we come. What is compilation?
Compilation is the process of converting source code into an executable program. In compiled languages, errors are caught before the program runs. The program must pass strict checks.
Yes. So that's compilation. We don't know what a compiler does. So compilation is the process of
Process.
converting source code. So source code is what you have written down, right, as a programmer, what you have written down in a programming language. Yes. So so a compilation converts it, or that process is the process of converting that source code a a form or into a form which the computer understands. Yeah. So it's also good to take note that what in compiled languages or languages that use this compilation process, errors are mostly caught before the program runs, and the program must pass. strict checks. Are we there?
Mm-hmm. Yes,
Okay.
sir.
So now let's do an introduction to Rust, the Rust programming language.
Okay. What is Rust? Rust is a modern systems programming language designed for safety, speed, and reliability. Rust as a strict teacher, Rust does not guess, does not allow sloppy thinking, forces you to be precise. Other languages sometimes, can you scroll on?
Yes.
Sometimes automatically convert types, allow unsafe behavior, hide mistakes. Rust says be clear, be correct, or I refuse to compile. That's why beginners learn strong fundamentals.
Yes. So these are one of the main reasons why we want to learn, we want to introduce programming with Rust because of these features of Rust. So these are
Okay.
features which will help you throughout your career or throughout your programming journey. Because as a programmer, when programming, you should be thinking of what? Safety. You should be thinking of what? Speed. You should be thinking of reliability. What you're coding, what you're writing down. How reliable is it? How safe is it? What's the speed? Because like I usually say, you two of you can be developing the same system, can be writing code to do the same thing, but you write that code, or the both of you write your codes in a different way, or you write your programs in a different way, but it still solves the same issue. Now, what
Mm-hmm.
will be the difference? What makes the difference between your program is what? The safety. How safe
Safety.
is it? Is the speed. Whose runs faster than the other? And how reliable is it? So in Rust, we're going to see all of these concepts and see how Rust implements them.
Okay.
Yeah. So there are so many languages out there, so many programming languages out there. So if you're creating a new language, then you need to stand out, or that language needs to stand out from the others. You get it?
Okay. Mm-hmm.
Yeah. And if many people are transitioning to Rust nowadays, it's because they've seen that Rust is that good. They've seen the value of Rust.
All
Are we
right.
there?
Yes, sir.
So we see that Rust does not guess, it does not allow sloppy thinking, and it forces you to be precise. Because most languages allow the programmer to do whatever they care or whatever they want to do. But Rust now, so unlike other programming languages, like some programming languages that are in favor, let put it like that are in favor of the programmer, Rust is like more in favor of the computer. You
Okay.
get it? Yes. So it's
So
like,
this is the same like Python.
yeah, Rust is a programming language like Python.
Okay.
Yeah, Rust is a programming language like Python. But let's not say it's the same, like, because obviously Python has its own different things, right? Its own things that makes it different, or let's say that make it Python.
All right.
Yes. Okay. So with Rust, so Rust says be clear, be correct, or I refuse to compile. Yeah, that's how Rust is. When we start writing code with Rust, you see that um if you don't follow its rules, it's not going to compile. And we have seen that what if your code does not compile, obviously the computer will not understand anything you're waiting.
Okay. Unlike the other languages that the computer will just do with the errors.
Yes, in other languages, the computer might just do the errors, and what will happen is when the code starts running, what happens? It starts crashing
Okay.
because remember the computer does not guess. So if it's running with errors, it means at some point what will happen? There will be an issue. So that's what Rust is
Mm-hmm.
coming to avoid. Exactly.
Yes, sir.
Okay. So let's continue. Rust is
Rust is a compiled language like C and C++. Rust is compiled. This means code is translated before execution. Errors are caught early. Performance is high. Rust statistically
okay. Wait,
Rust is
let me first of all explain
typed.
this.
Okay.
Yeah, so Rust is a compiled language. So like I said, languages can either be compiled or interpreted. So we have interpreted languages and we have compiled languages. So when you watch those videos that I was talking about, you get to know more about compiled languages and interpreted languages.
Okay.
Yes, so Rust falls under the category of a compiled language. So other languages which can be compiled are C. We have a language called C, the C programming language. And we also have C++. So these are all examples of compiled programming languages. And we have seen what compilation means already, right?
Mm-hmm.
Okay, so let's continue now.
Rust is statically typed. Statically typed means the type of every value is known at compile time. Example, consider number x boolean. Rust must know what kind of data it's dealing with. This prevents many runtime errors.
Yes, okay. So Rust is statically typed. So it means that you see, it means the type of every value is known at compile time. So remember, we have what? There's a compile time, we have something we call compile time, and we have what? Run time. So compile time is when what the compiler is doing its work, right? And what does the compiler do? The compiler checks for errors. So it
Just
checks for
code
errors
to
first, right? Before translating it to binary. Are we there? Yes.
yeah.
Uh-huh. So what we are saying is, what do we mean by statically typed? When you are writing your program, Rust needs to know what your values are. So you need to tell Rust that what this particular value that I'm using is a number. This particular value that I'm using is a text. This particular value that I'm using is a boolean. But when so I think you should know what booleans are, right? It's either true or false.
Mm-hmm.
Yeah. So that's it with us. You need to tell it what kind of data you are dealing with or it's dealing with. So for example, let's go to Bash since yeah, we're using Bash before. If you notice when we're creating variables in Bash, what do? We just say let's say name equal to Azibo. That's all right. Are you there? I'm not getting you as well. Can you hear me? Hello? Azubo, can you get me? Hello?
Yes, can you hear me?
Yeah, I can hear you now. I was not getting you before.
Ah, okay. I don't know why.
Yeah,
Maybe the network. Maybe the network.
maybe. All right, let's continue. So I was saying that, for example, in Bash, when wanted to create a variable, we could just say name equal to, I'll give a name. We
Mm-hmm.
could just say my age equals to, we'll give it, and then we'll put the age. But if you
Yeah,
notice,
in that.
we're not telling it that the age is going to be a number. We're not telling it that the name is going to be a text, which means
Mm-hmm.
Bash had to do what? Bash had to guess what the name is going to be.
Mm-hmm.
Because what am I putting that way? Because someone could still do what? Someone could still say name should be equal to 24, and Bash will not do anything. Because after all, you have not told it that name will only be a text,
Mm-hmm.
right?
That's true.
Yeah. So that's what Rust avoids. With Rust, you need to tell it that what this particular thing is going to be a text. This particular thing is
Okay.
going to be a number.
Okay. Okay.
Yes. So that helps to prevent things we call what runtime error. Runtime means that it's runtime means after the compiler has translated it to binary, an error might occur while the computer is running your code.
Okay. 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 Okay.
So that's what we're trying to avoid. Okay, so we're going to see that when we actually start writing code in Rust, you're going to see most of it. Okay, let's continue. Continue from here.
Rust, Rust safe and fast. Rust was designed to prevent memory errors, prevent crashes, be as fast as C, avoid garbage collection. This makes Rust ideal for operating system, embedded systems, web backends, and game engines.
Yes. So you see, first of all, you should take note of the different fields. Can you get me?
Mm-hmm.
All right. So first of all, you should take note of the different fields that Rust opens
Well,
for
Rust,
you. Yeah. So if you have if you have knowledge in Rust, so you can see that you have all of these options to choose from. And you see that Rust was designed to do what? Prevent memory errors, prevent crashes, be as fast as C. So the C language is very fast, and most systems use this C language because of its speed. So Rust also came in and tries to, tries to mimic it. Tries to be as fast as it. You get it? So they can also have those advantages that people who use C are using it for. Because C is a very old language, and if it's used right up to date, it stands to those advantages that it has. So obviously, if I'm creating a programming language, then I should try to look at a language, I should try to do as a language which has been like around for so long, right? Yeah, so that's it. Then garbage collection. So garbage collection here is um, you should not bother to. So Rust handles memory cleaning for you. What do you mean by memory cleaning? When you're working with programs, what happens? Like we said, things are being stored in a memory, right?
Temporarily.
Yes, temporarily. So at the end of when your program is done running, what happens? All of those things need to leave the memory. So they must not wait till you turn off your laptop before they leave the memory. So Rust can handle that for you automatically.
Okay.
Yes. Because why do we say so? Because some languages actually don't. So the programmer has to manually do it. So it's like it's actually a major thing in most programming languages.
Okay.
Yes. All right, let's continue. So continue from here.
Rust has a helpful compiler. Rust compiler doesn't just say error, it explains what went wrong, why it went wrong, and how to fix it. This makes it excellent for learning.
Yes. So that's it with Rust, right? Its compiler is very helpful. Like for example, we have done we have done we have written code in Bash, and you saw Bash errors. How were they? The errors that Bash was giving.
It just says line this and
It-
or error, but it does not say exactly what the problem is.
exactly, yes, that's it. With that's how the Bash that's how Bash was that's how Bash was created to give out errors. But you see, with Rust now is made in such a way that it can help you out. The Rust compiler. It tells you what went wrong, why it went wrong, and even gives you hints on how to fix it.
Okay.
Yeah. All right. So now let's go to section two, which is where we start writing code in Rust. Are we there?
Yes, sir.
Okay. Just give me a while, let me
Fir-
come back.
Okay.
Okay, are you there?
Mm-hmm.
All right. So now let's now move to doing. Let's start writing some code. So let's start here. What is source code?
What is source code? Source code is human readable instructions which you write.
So we have the example there. So this example is in the Rust programming language. So that tells you that what your source code can change. Your source code can change based on the language you're using, because this source code is based on the Rust programming language. If you're doing Python or if you're writing your code in Python, Python has its own syntax, right?
Mm-hmm.
Yes. So this is based on the Rust programming language. So this is Rust source code. So now let's see what all of this is. So what is main? So every Rust program starts with this. Are you seeing?
Mm-hmm. Fn main in brackets, then inside main bracket now.
Yes. So that's it. So main is the entry point of the program. So on my entry point, what do we mean? So when a program runs, the computer will look for what? Main.
That Fn stands for find main.
This fn stands for what? Function. So we want to create a function called main.
Okay.
Yes, we want to create a function called main. So this main is a default name. So that function must always have the name main.
Okay.
Yes. So like I said, main is the entry point of the program. So when a program runs or when a Rust program runs, the computer looks for main, and that's where execution begins. So which means that what? If there is no main, the program cannot run.
Okay.
Yeah. So that tells you that whenever you are writing a Rust program, the first thing that you should write should be this before any other thing.
Will you write the thing that you want to write inside those brackets, or I don't understand?
Yes, you write everything that you have to, everything that has to run will be inside those brackets.
Okay.
Yeah. So we're going to see how it's going to be. We're going to see that everything is going to be written inside. And you're going to see how it's going to be written too.
Okay.
Yes.
So that are we going to be writing that on the terminal, or it's another platform that we'll download and install?
Yes. Well, we can also use the nano just like we're using by we're writing for bash, we're using nano, right?
Mm-hmm.
But for this one, I prefer that we there's a different software that we're going to be using. That's
Okay.
going to it's going to make life a little bit easier for us.
All right.
Yes. So you see in this code, so this is the code. So I've seen what this fn main is, and we've seen why we need this. Within it, our line of code or our instruction. So what is this line of code? This one, what is it? What does it do? So that tells you that when you run code, the computer first of all looks for this main. When it sees main, then it's like, okay, then I can start reading or start doing what's inside the main.
Mm-hmm.
Okay. So let's see what this line does. So first of all, the first thing that you see there is this print line. So you see print ln, then exclamation. So I'll call it print line.
Okay.
Yes. So what does it do? it prints text to the screen.
Okay.
So when you write this, you're telling the program or you're telling the computer that what you want it to print hello to the screen. So this produces output. So important, this sign, this exclamation like this means it's a macro. But don't mind, we're not going to dive deep into it. You just have to understand that this is if you want to display something or display a specific.
Live streaming is on.
Okay. So that's clear, right?
Mm-hmm.
Okay. So what was the similar command that we're using in Bash to display text, to display something to the screen?
Is print air. Is print
In Bash,
or
we're
echo.
using print. Exactly, we're using
Echo.
echo. Yes, in Bash we're using echo. So that's to tell you that this print ln with this exclamation, it does the same thing that echo was doing.
Okay.
Yes. So that's it. But now, obviously, based on Bash, it will have its own different things. But the main thing is that it displays things to the screen.
I think even cat does the same thing.
No, cat's own is that it displays what's inside a file, right?
Yes, 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 yes.
So that was it. All right, let's continue. So now let's see how we can install and check if Rust is available in our system. So the first thing, let's run this command in our terminal to check if Rust is there.
Okay. Should I do that? Should I do it also on my terminal?
Yes, do it on your terminal. And share your screen too.
Okay. One moment, one moment, one moment. Can you see my screen?
Let me check. Yes, I see your screen. Can you get me? It looks like your network is breaking.
Yeah. It says command C not found, but can be sudo app install Rust up version 1 or sudo app install C version Ubuntu. Can you hear me,
Okay.
sir?
Yes, I can get you. Yes, I hear you. But I think let's go
It
to the
says,
first. Can you hear me?
let's go. Yeah, let's go to the.
Yeah, go online and search for Rust. So Rust. So go to Rust.
Down.
Just search. Just search Rust, and then the first link you see install Rust. Can you see it? Can you see it? Are you there?
I'm seeing installers.
So yeah, it's August. Look at this line. I see. Can you see my screen? Look at this line. You can copy it.
I'm putting a
So
terminal.
yes, so I've copied my own. So I'm going to also add it to the terminal, and then you run it. So you hit enter for it to go download or install.
It's showing info downloading installer.
Okay, so allow it to do its job. So
But this
you
guy
should,
is saying that we could just do sudo snap install.
no, I don't
Will it
want
be
us
an
to.
older version?
That's the issue. Yeah, it could be an older version, so it's always preferable to go to the documentation that's online. There's a great chance that you get the best version.
Okay.
So you should see you should I think he has displayed you some options to follow.
I see. Mine is still showing downloading.
Uh, because it will show you an option like options one, two, and three.
But I don't know, like, can you see my name?
Let me check. E, I'm still seeing downloading installer. Or has it changed?
There is a white cross that allows and type. I don't know this one.
Cannot get you well.
It changed. And installation.
Your voice is breaking. I cannot get you. Or stop sharing and because it started when you started sharing. You can just stop sharing and tell me. Hello.
Yes, can you hear me?
Yes, I hear you.
It's still down. I don't know.
Wait, did you take any option? It shows that you
It
took an
shows.
option. Which option did you take?
I don't know, sir. I don't know.
Because
I
it shows
don't
that
know. I don't know.
because it shows that option has already been taken. No problem. Just continue.
It says current installation options default host process installation one. The cancel installation. But all these ones that are just going, I'm not the one pressing them.
So yeah, allow it to continue. I think it's downloading the default one.
Oh, you wanted to do another a different one?
No, that was the best. That's the one I wanted.
Okay.
So we'll just give it time for it to finish and then we'll continue. So when it's done, you let me know.
All right.
Is it done? Is it done? Okay. Cannot really get you. I think when you're done, you can close your terminal and open it again. And then you type that command to check if Rust is installed. That command which is in the notes. So you can look on my screen to see.
The thing is, I'm doing. If I press enter, you download. I don't know. I don't have to press anything. Am I doing the right thing, sir?
I'm not seeing your screen. When
Let me share
when
again.
I don't see your screen like that.
If I click enter, it's going to go to the next step, start downloading over and over.
Maybe I don't think it's done downloading. Just wait. When it's done, it's going to stop on its own. Don't need to click any enter or anything.
Okay.
Because at that point, because it depends on internet speed and other things. But mine is already done, so we'll just wait for yours to complete.
Okay.
Okay, just give me some time while yours is still going. Let me go and check on something.
No, my parallel, the internet coverage here is big. It just is better. I was in the room. Really should put on the rubber. This is usually done by running a following. So it's like it has completed, eh? Are you there, sir? Are you there, sir?
Azibu, how is it?
I started the process back. So look at my screen now, please.
Okay, let me see. Okay, I choose
It has.
one,
I should. I
and then
should. I should delete it greater than. Or I just type in one.
no, just one and hit enter. That's all.
Correct.
Yeah, I'm the one who is here.
You see, yours is installed now.
Wait a minute.
So when I run this ROS slash light version, it shows that it has not gone. Yeah, you also. So I should restart my current share.
Yes, close your terminal. Can you get me?
Yeah, I'm reading the instructions. Let me do it.
Close your terminal and then we open it.
Well, it's available now. So is the current version. We will not need to update it, right?
No, don't need to update it.
Then now on the note it says it should display something like ROS one XXX. Okay, these digits.
Yeah, that's the digits. Whatever digit it gives you, that's the main thing.
Okay, okay.
Yeah.
So it does not
Okay,
have like
give me a while.
it
Just
does
give
not
me a
have
while.
like
Let me sort out something. Yeah, hello Azibo.
Yes, sir.
Okay, we can continue now.
I was even trying some things, but I don't know.
Okay, all right. So we have to install Visual Studio Code because that's what we're going to be writing our code. Okay, I see what you have been trying. That's good. Should I just be following the
Mm-hmm.
yeah. So
So
we have to
that
install
now
Visual Studio Code. So go
on
online
terminal.
and then no go to your browser and type VS Code download. Can you see what I'm typing? VS Code download. So you take the first one
On
that
link.
says download Visual Studio Code Mac Linux Windows. Then you take the one for are you seeing this the dev.
Mm-hmm.
Yes, click on it to download it. So you should be downloading now. So when it's done, or another way, go open your app. Are you seeing this A icon that's to the left of your laptop? On that icons bar, that A, can you get me? Can you hear me? Can you hear me? Can you get me? Azibo, Azibo, can you hear me, Azibo? Can you hear me? Azibo, Azibo, can you get me? Can you hear me? Hello, Azibo, can you get me? Azibo, Azibo, do you hear me? Wow. Hello, Azibo. Azibo, do you hear me? Azibo, hello.
Is on.
Are you there, sir?
Yes, Azibo. Welcome back.
Okay. The download got finished. What should I do next?
Just wait. Let me come back. So I was saying you should look at the that icons bar at the left of your screen. You see an
Where?
icon there, and
This
you
one.
uh share your screen so I can fix it.
Can you see it?
Let me see. The screen is still dark. Okay. Okay, I can see the screen now. So you can see those icons to the left. That up bar or the icons bar. You can see an icon there with A.
Wait,
It's called the App Center.
two apps.
No, no. There's an icon there with A. Those, you
Mhm.
see, yes, that's one App Center. So click on it. Yeah, you should see the search bar. On it, search James code.
Which one? The first one?
Yes, the first one.
I think install.
Yes, click install. So that should make the work easier. So is it done? Let's continue.
It's still showing installing. But
Okay,
soon
when
it'll
it's
be
done, we'll
done.
see. Azibo, how is it?
Very soon it'll be done.
Okay.
I've opened it.
Okay.
Say use AI features with Copilot for free.
Just hit mark as done. Okay, so let's go back to the notes. I saw you have already created a directory and you've already done cargo new first program, right?
I did not. I just copied. I just checked the ROS version after I just said cargo new first program. I don't know what he was doing. I was just following
Uh,
him.
but did you read? I mean, you have to read it, right? Did you read what? I
I
mean, you don't just need to
tried,
copy code.
yeah, I tried. I tried reading.
So
They
that
said
cargo new first program creates a project.
so the command cargo new he created that file that first program.
Yes, so it creates, yes. So the command is cargo new. So cargo is the package manager for us. So it helps you to create programs with Rust or to create projects with Rust. It helps you to build your project, to compile your project. Yes, so that's what Cargo does. So when you use Cargo new, it means that you're telling Cargo to create a new project. So you need to give the name of that project. Yes. So now that you're within it, you've done LS and you've seen what it gives, right? So what we should do now. So I think let me also create mine. So I'm going to create CD into, let's say, documents. I'm going to
I just
create a,
I just did mine on the desktop.
oh, I see. So let me go to the desktop too and see. CD dash desktop. So
Not
let me see
actually
which folder is.
not actually the desktop from the root directory. If you look at mine, I did not go into the desktop. I just went there, just did it live.
It's not good to do that there. It's always good to enter one of these other directories.
Okay, let me delete these ones and do back. Let me see.
Yeah.
RM. Let's see. C CD RM first underscore program.
So it won't go because that first program is a directory. So you have to use dash R, RM dash R.
Okay. RM first program. So this command is working in the first place because we have already installed Rust, right?
Yes, that's why cargo new is working. So that's why
Mm-hmm.
cargo is working. So every programming language has its own way to install. So this is how we install Rust. When you notice bash, we don't install anything. So are you there?
Mm-hmm.
Okay. So now for me to open this first program on VS Code, that VS Code which I already installed, you have to go and open VS Code. Are you there? Go to VS Code like you opened it already.
Mm-hmm. Open your file.
Then no, open new folder, open folder. So just go up. No, go up to where you see file on the yes, click on it. Oh, what happened? Yes, so there you see open folder. Yes. Then
It has opened.
navigate to where your folder is found. So yes, click on first program. Just click and open it. No, come out. Yeah, just click on.
It's no longer going.
Yeah, see yes, just click open now. No, no, don't. If you see it should be open somewhere.
Yeah, I've seen open.
Or set yeah, that's it. So it's opening now on VS Code. That's clear, right?
So do you trust the authors of the file in this folder? Trust the
Yes.
authors in the parent folder lecture. Yes, I trust the.
Yes. Choose yes, I trust. So you can
It says Git not found. Install it or configure it using Git path settings.
so yeah, you have to install Git. Go to your terminal. Oh wait, what is this saying? Does it say the download Git? If you're showing download Git, then just download it from there.
It was open in browser.
Oh, in the browser. Yeah, click on
That's
Linux. Yeah, use that first link. Then you need to use sudo, right?
I should come out from these directories first now.
No, there's no problem.
I don't need to
Click on
come
this
out.
link. You don't need to come out. Yeah, hit enter. Yeah. Yeah, so while it's downloading, let's continue with our Rust.
It's at 92%.
Yeah, no, allow that one. Let's go back to VS Code. That's not even necessary for us.
It has finished downloading, by the way.
Yeah, just leave it. We don't need it. Go to VS Code. Let's continue.
I should go and do back. The stuff has already marked. I should mark down here.
Yes. Wait. Go back to the notes. So you should see that what we have. Go to project structure. I see the project structure. So you see that first of all, before that project structure, it says cargo create a folder. And you have seen the folder. The name of the folder is first program, right? And then it sets up the project structure and creates a default main.rs. So if you look at the project structure, you see that what you have inside first program, you have cargo.toml. Can you see it?
Yeah, there's in the VS Code.
No, I mean on the notes. I'm still on the notes. You see cargo.toml, you see SRC, there's an SRC folder, and then there's main.rs. So now go to VS Code and look at them.
That this SRC means source.
Yes, it means source. Not just a folder. It's SRC means source. So just give me a while. Let me finish something.
Roderick.
Okay, Azibo, can you see it?
Mm-hmm.
Okay, so you can see a cargo.toml. I'm sure you're even seeing other things there too.
Yeah, this is on VS Code.
Yes, on VS Code, you see other things. You see, but obviously you are seeing cargo.toml, you are seeing the SRC folder, and within the SRC folder, you are seeing
The main
the
dot,
main dot.
the RS.
Yes, that's it. Hope it's fine.
It shows that the cargo term L is actually describing what's in the code.
Uh, Not necessarily. The cargo.toml, if you see it, it's it's describing your project as a whole. That's why I see it gives you the name. What's the name of your project? You see first program, which is the same name that you gave, right? And saying the version, like the version of their program is that's like the first version. That's why I see 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. and then edition is based on 2024, or as in that's like should I say, I don't really know what to describe that particular one, but the main thing is that cargo dot thumbnail just gives you a description of your program, of your project.
Okay, okay.
Yes. But go our main part now is, you see, running the program. Can you see it?
Wait, I'm not seeing your screen. Let me see. Yeah, cargo
So
run.
running the program. So you have to go to your terminal. So go to VS Code. VS Code has a terminal in it. So, first of all, look at my screen. Let me do it. Then you'll see what to do. So I'm going to go to VS Code. I'm on VS Code. Then on VS Code, I'm going to click this. Are you seeing?
Toggle panel.
Yes, toggle panel. But look at this particular one that I'm clicking. Because you see that three of them here.
Okay,
So I'm clicking this one.
okay.
So I'll click on it. Are you seeing? You can see terminal here.
Mm-hmm.
So that's my terminal. Within it, I'm going to make sure that, look at, I'm inside first program.
Mm-hmm.
Then now I'm going to do what? Cargo run. That's it. Yes, run my Rust program. And what can I say? Hello world.
All right.
Yeah. So now go
Let
and
me
do the
check.
same.
Mine says error.
Just says error. Let me see. Let me check what's the issue. That's strange. Um, it says compiling first program link assist is not found. That's strange.
Well,
Check
it's like I did not.
um
Let me go to my terminal and see.
what do you want to check?
Uh, let me see. Mine has all those documents. Cargo log, cargo.
Yes, yes, that's fine. Maybe there could have been an issue when you were downloading Rust. So go back to that Rust documentation and try to redo it again. Let's see.
Where to Ross?
When you're installing Rust, so go back there and run that code, that link, that command that was there.
It says
So
proceed with.
score up. Let me see. No, score up using your mouse. Okay, use one.
Should I
Type
cancel
one
it?
and hit. No, type one and hit enter. So it shows
This is
that everything is already there.
But I'm seeing one in some places.
No, that's not an issue. I don't understand what's happening. Go back to your terminal. Let me see. Go back to your VS Code terminal. Um,
I should remove this first file. I should open it back from the beginning and do it.
no, no, no need. Go to main.rs. Let me see. Okay, main.rs is fine. Try to do it from your terminal. Let me see. Just run cargo run from your main terminal. Do this, yeah, cargo run. The same thing. Copy the error and paste it in your browser. Let's see. Search.
Nothing shows.
Go to AI mode. Yeah, so copy that and run your terminal. So after that, we should be able to build and run.
It's done.
Okay, do cargo run again. Let's see.
It has worked.
That's good. Try it now, VS Code.
It's good.
Okay, now we can proceed. So, so first of all, you have seen how to download VS Code. You have seen how to open the terminal on VS Code, and you have seen how to run your Rust project.
Mm-hmm.
Yeah, so that's fine. So now let's continue now with the next thing. So let's continue with notes. So you see that we have cargo run to run it. So what does cargo run do? It compiles the code, it runs the executable, and then it displays our output.
Mm-hmm.
And
And
by
it also
using
It also works like that on the terminal, so we never really needed VS Code to run this.
Well, we needed VS Code. VS Code, the main reason why we need VS Code is never be about the running. The VS Code is not even there for because of the running. VS Code's own main work there is it serves like what, just like what we're using Nano to do.
Okay.
Yes, we're using Nano to write our code, right?
Mm-hmm.
Yes, but now we start you see that VS Code we can use VS Code to write the code, and then VS Code also has a terminal again that we use to run our code. We don't need to write on VS Code then close VS Code and go and run elsewhere. No.
Okay, you can just do it one time on VS Code.
Yes. So that's the advantage of using VS Code. And many more. That's not all, Amy. So don't mind. With time you see other advantages of using VS Code.
Okay.
Yeah. All right. So let's continue with our notes. So so for the first Rust program, you find it where in the main.rs, right? So if you go to your main.rs, you see this program there.
Uh-huh.
I'm sure that's why you understood. You understood why when we ran it, we saw hello world, right? Because we're going to explain this code. So let's explain it again. So fn means what? Function. So function, so where I write fn is telling you that way you want to create a function called main. And we're seeing what main is. Main is the starting function or the starting point of your program. And then within here, within this curly brackets, you need to put what? Your code block. So whatever instructions you want the computer to do, they need to be inside this curly brackets. For example, you can see that print line is within the curly brackets. So when we writing code, you see at times we have code inside the curly brackets and we have some code outside the curly brackets too. So there's no problem
Okay.
having code outside the curly bracket.
Okay.
But the main thing is if whatever code is not, if you have any code that is not inside this curly bracket, means it's not going to run. Do you understand?
Mm-hmm.
Yeah, like we said, for code to run in Rust, it has to be within the main function.
Okay.
So if you put any code outside, it means you don't want that code to run. If you want it to run, then you need to call it inside the main function. So we're going to see how we can do that.
Okay.
Yeah. Okay. So enough with that. Let's do this exercise. So the first thing will be for you to create a new Rust project called introduction, and then within it, you want you to print your name and age, and then write a short sentence about yourself. For example, this.
Okay. So
So
I have to go back to Ross lecture, create a new directory or what? A new
yes, that's what you have to do. You create a new Rust project.
that means I have to create under Ross lecture. I have to create a new folder.
No, don't create any folder. Just use cargo new and create a new project.
Okay. Cargo new introduction. Enter. So I have to go now to VS Code.
Let me see. Have you created it? Yes. Now go to VS Code and open it. So you do the same thing. Go to VS Code, you go to File, and you see Open Folder. So you are safe. Okay, no problem. So we're going to be using VS Code for everything now. For all our writing, to write any program, we're going to be using VS Code for that.
Okay, that means terminal will no longer be important.
Now the terminal will still be important, just that yes, we'll be using more of the VS Code terminal now.
Okay. So I have to come and edit here and put what they asked me to do
Yes. So the
instead
first
of
one will
this
have
hello.
your, yeah, the first one will
I
have
have
your
to just,
name, the second one will have your age, then the third one will have something about you. So are you seeing what VS Code, are you seeing how VS Code is suggesting things for you already? But we never ever
so
had that for Nano.
so it shows only hello world,
Yeah,
not what
the
I've.
issue is the issue is because you have not saved your file.
Oh. So how do I do that?
So it doesn't know that there's any change. That's why you're seeing that one. I seen that one that you're seeing the one.
Yes.
Yeah, that one means that there's one file that has not been saved. And also, if you look at that main.rs there, you're seeing a dot, a white dot. Yeah, that white dot tells you that main.rs has not been saved. So to save, we have to hit Control S. So now it's saved. You see that one has come out, that dot has come out.
It shows error. Help add Let me try to see what is the problem next.
Yeah, first of all, the first step to check how what the problem is for you to read the error well. Like I said, like we saw, they said that what the Rust compiler gives you hints. So read the error and see the hints that it's giving. Are you reading it? Read it out loud so I can guess it.
Oh, expected is an iPhone.
So it's expecting a semicolon.
Mm-hmm. But now it's like I didn't put it well.
Yes, and that's why you see under give you a hint. It's showing you can help. It's showing you where to put it. Look at the arrow.
Okay, yeah.
Hmm.
Even here, I have to do the same.
Yes. Because if you go back to the error, you see, look at it's showing you line 3 and line 4. So it's showing you that those two lines need to be, that's where the error is found. So you said that's the advantage of using a compiler. You see that it has scanned through your whole project and it's showing you where errors are found. But you see that Bash was not doing this. Why? Because, like we said, Bash, there's another form of languages that don't use compilers. So Bash is one of them.
Wow, it has worked now.
Exactly. So that's good. You're done with your first project or your first program.
Okay,
So that's Rust. That's a brief overview of Rust. So that we're done with lesson one.
okay.
So let's look at the next lesson. So you can see programming foundations through Rust 2. Have you seen it?
From output to data to decisions. At this point,
Yes.
students will know a program is a set of instructions. Execution starts in main, code runs top to bottom, ROS compiles before running. Now we move to something critical. Programs
Yes.
become powerful when they can store data and make decisions.
Exactly. So now let's see how do we store data in Rust or in a program. So we use something called variables. So what is a variable?
A named location in memory used to store data. Think of it
Yes,
like a code box, a container, a drawer with a name. Example in bracket real world analogy. Box labeled age inside 20. So
yes. So it's like when we say age equals to 20 now. Yes. So that's just a variable. A variable just helps to hold value. So when you
okay.
create a variable, what happens? Space is being reserved in the memory of a computer,
Okay.
and that space is going to store a specific value. So in this case, the space stores what 20. And that space now, you the programmer can reference that space using what? A variable name.
Age.
So in this case, age, yes. Yeah. So in programming, you see age equals to 20 or age has 20. So the name helps us to access the stored value. So whenever I in age, another age is equals to 20. So continue from here.
The name helps us to access the stored value. Data is stored in memory. When your program runs, the computer allocates memory. Variables live in memory. Each variable has a name, a type, and a value. Memory is not magical, it is structured storage. Rust forces you to be clear about what you are storing.
Yes, very true. So that's very clear, right? Any question?
Mhm. Mm-mm.
Okay, let's continue.
Why data types exist? Data types exist because the computer must know how much memory to allocate, how to interpret the data, what operations are allowed. Example, 20 as a number can it means can be added. 20 in parentheses text cannot be added like a number. What does that mean, sir?
Yeah, what we're saying is this first 20, if you tell the computer that this 20 is a number, then the computer will understand that word. This, you can add a number, you can subtract a number, you can multiply a number, you can divide a number. But now this second
Okay.
20, now which you are telling the computer that it's a text, then automatically the computer understands that word. This now automatically it understands the operations that can work on that number. It knows that okay, this thing, this one is not a number, it's a text. It means that what addition cannot go on it, multiplication cannot go on it, division and all of those things that we used to we all of those operations that work on numbers cannot work on this. Is that
Okay.
clear? So
Mm-hmm.
that's why it's necessary to give the data type or to give a type of a variable.
Okay.
So you can see they say this prevents nonsense. Okay, let's continue. Variables in Rust.
In Rust, variables are declared using let variable underscore name equals to value.
Yes. So
Example,
for example,
let age equals to 20. This
so that tells you that word in Rust, whenever is used let, there isn't let, it means that word you have to create a variable.
okay.
So yeah, you see, let age be equals to 20. It means you're creating a variable called age and you're giving it the value 20.
You see, Rust variables are immutable by default. This is very important. By default, Rust does not allow you to change a variable. So if that means we are just trying to say that if you have already said if let age equals to 20, if you come now and write in the code that age equals to 15, like they have said here in score, it will give an error because you actually define that let the age be equals to 20. So if you change the number, you will not it will produce an error, correct?
Yes, that's very correct. That's what it means.
Okay.
Yes. So when we say something is immutable in programming, it means that thing cannot change.
All right.
Yes. So by default, all the variables that you create in Rust are immutable. If you use let, right, by default it's immutable. Or if you just say let score be equals to this, by default it's immutable. So now let's
Mm,
see how we can create variables that can allow changing.
okay. Ross will refuse to compile. Why? Because Ross assumes data should not change unless you explicitly say so. This prevents accidental bugs. Mutability, allowing change. If you intend to change a variable, you must say so. Let mute score equals to 20, equals to 10, score equals to 15. Mute means the value is allowed to change. Okay.
Yes, so that's it. So you see that with God's, you need to be intentional. You need to say what you want. You need to be space like it's like with the God's, right? The God's expects the programmer to know what they are doing. Like don't just guess things, don't just put things there and expect the computer to guess that that's what you want it to do.
Okay.
Yes. Which is a very good approach. It's a very good approach.
All
So
right.
let's yes, so let's continue. We have many exercises on that. So primitive data types.
Primitive data types are basic building blocks. Integers, whole numbers, examples, minus 10, 0, 25, 1000. Common integer type, let age hyphen semicolon I 32 equals to 20.
Yes.
I
So
32
when
means
yes, continue.
single signed integer, 32 bytes, and can be
Bit.
positive or negative.
Yes. So so we have seen how to declare, how to create variables in in Rust. So can you see my screen? I'm on VS Code.
Let me go to your screen. Yeah, I can see your screen.
Okay. So I'll just cancel this line and then I'll create a variable. Let's say score be equal to 20. So take note of the fact that every statement, or yeah, every
Hence,
statement in yes ends with a semicolon. It's very important. You notice that your code did not run only because that semicolon was not there, right?
mm-hmm.
Yes. So I've created a variable, let score be equals to 20. And like we said, if I want to change score, it will not work, right?
Mm-hmm.
Live streaming is on.
Okay. All right. Let me continue. So let me run this. Okay. Cargo run. So you see that I have an error. And like I said, always have that build that habit, right, of reading through your errors to see. The more familiar you're with errors, the better you will easily catch errors yourself before even running.
Okay.
Yes. So you see that it tells you cannot assign twice to immutable variable score. So this really telling you that what score is immutable, which means it cannot change. So you cannot assign a value to it twice. Yeah. So and then they go ahead to tell you that what in this line, let score be equals to 20. You can first assign it. Tell you that this is the first place where you assign a value to score. And then it's coming to tell you again that what you cannot, this line cannot occur, cannot assign twice. And then it gives you help. Are you seeing? So it says
Considering
consider
the
making
binding,
this binding mutable. So consider making score mutable, and then it tells you what to do. Man, this is so awesome. It's cool because you hardly see a programming language that will give you this kind of help.
okay.
Yeah. So you see, it tells you that do this, and then now it gives you like different warnings and all the rest. So let's go ahead now and make it mutable. So let's mute. score be equals to 20. But there's an issue. So VS Code can do a lot more. Did you notice that even there's a way in which we can use VS Code such that VS Code will even show us errors before we even run.
How is that, sir?
Like now we have an error, but we cannot see it. So what can we do? VS Code has something we call extensions. Can you see?
Mm-hmm.
So I'll click on it and I'll install extensions that can help me to like they add more functionality to our text editor or they improve it.
Okay.
So I'm going to just type Rust and here I can install this first one. I'll install
Okay.
this and then I'll install the second one. So you can see 5.8 million people are using this one. So that's why I'm installing it. So it's installing. So that's it. I'm done. So you can go ahead and install it on yours too.
Mm-hmm. I'm already searching.
Okay.
I'm seeing Ross 826K people using.
Yes, so take that. So you just need to take that. It's going to install all. It's going to install all what you need. Yes, trust.
This one will
Is
help
it
detecting any errors on the video.
come again? I cannot get you.
This will help to any errors.
Is everything is just breaking now. I don't even know what I'm saying.
I'm asking that.
Hello?
Yes, can you say?
Yeah, I get you now.
I'm asking that these plot extensions, that means they help to take out while you are still on the VS Code typing.
Yeah, like they have their own different things that they do, right? So um yeah, they help to do different things. So some will help to show you your errors while you're still running. Some will, in fact, they all have different functionalities. And now I want us to install another one called
Okay.
error lens. That's actually the one that will show you your error lens. And then there you also see error gutters.
When you say error lens, is that bad? It's, I don't know.
You just have to type error. Don't like you must not type the full name. Just type error. So you see error gutters.
Okay, I've seen error lens.
Yes, so install it and also install error gutters. Okay, I think after that now we can continue with our work. Well, we are ready. So can you see my work now? Can you see how I see my errors? It's really showing my errors.
Let me see your screen. Wow. How did you do it?
So, I mean, those are the advantages of using VS Code. Yeah, VS Code is a modern text editor. So you see that it comes with different plugins and functionalities that can help you to do many things already. So it's that already
Yeah,
here.
it
Look
gives
at
why.
it's giving me hints. Are you seeing? If I click on, it's telling me that what this guy, this is I-32. So what's I-32? So that
That
I
means it's
is an integer. It's a 32-bit integer. And you see that it's really telling us here that cannot assign twice.
but now that means it's supposed to be like is a whole a negative number now. What was
No,
it
no,
trying to
no.
explain in the notes?
No, I-32 means it can be any number, either negative or positive. The main thing is that it's a whole number, decimal.
So, but now you cannot change it because you did not put a mute. Let mute score equals to I.
Exactly. So if I come here and put what mute now, everything should be fine. Are you seeing?
Wow.
So you see that I'm no more having the red again. Yes. So most of the times yellow is just a warning, so you can ignore it.
Okay.
Yes. So that's fine. So now if I run it, everything should be good. So you see, I just have the warnings, but there's no issue. So this warning is just telling me that what I've created a variable, but I've never used it.
Okay.
Yes, that's it. Okay.
So when
So let's
it's red, there's an error.
yes, when it's red, there's an error, which means there's a high possibility that it's not going to run.
Okay.
Yeah. Okay, so if we go back to our notes, we're going to see that what we're now reaching data types, and we're seeing that what I-32 is an integer, a 32-bit integer.
Yeah.
And integers are what? Whole numbers, either positive or negative. Yes. So we also have what? Floats. Floats are decimal numbers. Like you see, let's hide F64 equals to 1.75. So, but what I want to show you is you can see that what when I was creating score, I did not put, I know say score should be I-32, but by default, um, Ross understands it's an integer, it's an integer, a 32-bit integer. Why? Because of this. Since I assigned an integer to it, so Ross will automatically understand that what this is an integer. But you can do what? You can also be explicit about it. Like I say, what? Let's mute age, which is I. Are you seeing suggestions that are coming? So you said there's I8, there's I64, there's I32, there's I16, there's I128.
Those are different
All of these
integers.
values, no, yes, all of these values, right? They tell you the size of the integer. So the greater the value, the higher the higher the capacity, the higher the number of integers it can hold.
Okay. For
Yeah.
example,
Like for
if, if we put I8 equals to 300, is it going to hold?
like I8, like let's say I8, I think it should be able to hold 300. It should be able to hold 300. Maybe, but I don't think it will be able to hold. Let me say if I put, let me just put a very large amount. They're not really show us here because I think it's going to, it's going to take care of itself on its own. But the main thing is, yeah, the main thing is the fact that you, the programmer, should be able to know that okay, if I want to use I8, it means I'm expecting that, okay, my my number should not be that much. So I8 is equal to what? It's that's 8 bits, right?
Mm-hmm.
So this slash that I put here, this for a comment. So 8 bits means one, let's say maybe 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 bits that's there.
These two
It's
slash
8
slash
bits.
they are coming. That means it will not print out when the code will be run. It will not be.
Yeah, the compiler is going to ignore it. It's like just going to skip it. You get it?
Okay.
Yes. So if let me just go to say something here. So if I say I 8, so let me say how many integers can I 8 hold? So total combinations 2 to the power 8, which equals to 256. That tells you that what for I8 can hold what? Okay, from minus 128 to 127. Are you seeing?
Oh, mm-hmm.
Yeah,
Yeah.
which means above 127, it will not be able to hold.
Mm,
This for signed, just like I8 guys, for signed ones. Then
mm,
when it's unsigned now is U8. Is unsigned, it means that you can only hold positive, right? So you can hold from 0 to 255.
okay.
Yeah. So that is the same thing. So how do we get to see 2 to the power 8? Which means if it's I32, be 2 to the power 32, right?
Mm-hmm.
Yes. So that's why you see by default they give I32 because at least it gives you some kind of average capacity that maybe at least every number can hold. It can every number should be able to enter there.
Okay.
That means if I'm using I8, then I'm expecting that this 300 will be too much for it already, right?
Mm-hmm.
Yeah. So let me try to print it and let's see if I print. So if I want to print, take note of how I'm going to print it. If I want to print an integer or a variable, I'm going to use this, the curly brackets, and then comma or put h.
Your screen has been turned off. It has come back.
Okay. So this acts for like what? A placeholder to tell us that what in this space I want to use what? I want that h should be in this space.
Okay, 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 okay.
You get it? So let me run it.
Google run.
Yeah.
You do not save, sir.
Oh, thank you. Let me save. Okay, you
Literally.
see, I've saved it now. It's telling me that there's an issue, right? It's out of range.
Mm-hmm.
So it's out of the range of for I8. And then you see that telling us how what's the range of I8 from 128 to 1 from minus 128 to 127. So I mean you can see this is really cool, right? The fact that they're telling us everything, they're explaining to us so that you yourself should know that what this your I8 that you have used here is too small to hold this number.
Yes, sir.
And from here to you also understand you can see why it's good to give the data type of a number of a variable. Because when we say I8 here, the computer will reserve space that's equivalent to hold a number of this capacity.
Mm-hmm.
So as such, the computer will not waste space. So in this case now, since we're seeing now what I8 is too small, we can change it. Let's say I16,
Oh, I-32.
yes, or I32. You get it right? Yeah, that's it. So if I wanted but a decimal, I can say okay, let's say um let's let GPA be equal to let's say 3.76. So you see by default, Ross has understood that what this is a float. I see F64.
Mm-hmm. But you're not the one who
Yes.
types it.
Yeah, I've not written it actually. I've not written it. Is VS Code that is remember we install those extensions, right? It's one of them that is putting this for me. It's like showing me that is what Ross is saying this thing. So if it's like change the terminal, so if that's not what you meant, you can change it yourself.
Okay, okay.
Yeah, so it's not actually there. It's the extension that is showing us that you should know that this is how Ross is seeing this thing.
That means it has made the process more easy.
Exactly. Okay. So that's we're seeing floats. So in programming we call there's a data type. So we call decimal numbers floats. Yes. So we have seen integers and we have seen floats. So common float types are F32 and F64. And then we have booleans. Boolean is equal to is either true or false. So let is students be equals to true. So you can say bool. When you put bool, it means that what it's either it will be true or false. So that they're not expecting any other thing. It's either it's true or it's false.
It's for used in decision making.
Yes. And then we have characters. So character is also a data type. So single characters. So it's for single characters like what? See A, just a single character.
It should be in that bracket, in that parentheses. That's very
In this
correct.
quotation, single quotes, yes. So you see that word important. Character uses single quotes, while string uses double quotes. So take note of that.
Okay.
Then now let's see how what strings are, how we can write strings. So you can either call it strings or text. So we have two forms. Two forms exist in Rust, but let's focus on the one now. So the first one is let name be equals to that. So you
Yannick,
see that you have, yes,
it's in double quotes. Double quotes.
ex exactly. So with this, Ross is going to see it as what? A string. So this is a string slice. So this how Ross, in this case, this how Ross will see it, a string. So we just need to, so just you just need to understand that this is how you specify the string in Ross. We're going to see the other method. Okay. So type annotation. So type annotations here is where you explicitly declare the type. Like you see, if you say let A and then you actually put it there that you want A to be I32. So yeah, this
Mm-hmm.
type, this type annotation. So let height and you say you want that should be F64. So you're telling us that you want that this should be a 64-bit floating point number. Same thing with a student. For example, bool, they're telling you that what this one is specifically a boolean. But also, like we have seen already, Ross is that intelligent too. Ross can do what? Infer types. Ross can often infer types. That means that what? Ross can
Mm-hmm.
guess what your type can be. Like say, let age be equals to 20. Ross guesses that your age is a 32-bit integer.
All right.
So, but most of the times when we work in, we'll be putting our own, we'll be explicitly putting it there.
Okay.
Yeah. So type safety. So Rust is statically typed. So that means types are known at compile time. You cannot mix incompatible types. So for example, let age be equals to 20 and let name be
Mm-hmm.
equals to Yannick. So if you say print line and then you see in this you set in this placeholder, right?
Yeah, that means for it to work, you have to put two placeholders.
No, in this case, look at that, put him a one thing. That's why it's just one. That's why age plus name. But besides, there will be an error because what? You cannot add a number and a string.
Okay.
Yes. So let me go back to VS Code and like you were saying that for that thing to work, I needed to put two placeholders. Like here we have age and score.
Mm-hmm.
So if I want to say okay, um, let me guide something. My age is and my score is, so in this place this will I'll put score, so I can come and put what, comma score. So that's going to tell us that what,
Mm-hmm.
in this first one I'll have age and in this second one I'll have score. Exactly.
Correct. Yeah.
Okay, and then let me run it. Cargo run, so you can see that's it there. My age is 300.
Yes. Yeah.
My,
Turned off. Yeah. Screen has
come
gone off.
again.
It just came back now.
Okay. So
It's
you can
okay.
see
I've seen
here.
it.
Yes. All that's clear.
Mm-hmm. Correct.
Okay. All right. Let's continue. Yeah, that's all about that. So let's practice this and let's end for today. This variables practice.
Write a program that stores name, stores age, stores height, stores a student true or false, brings formatted sentence. Example solution structure.
So these are example structure there.
So I have to go and create another folder, another directory.
No, do it on the same one that you're working on already.
Okay. Write a program that stores name.
No, you just have to use either true or false. You must not put the both. So you can only
Okay,
do
sir.
one of them.
So these ones I have put now. I have to put now the variables. These are the variables I have put. Now I have to put now the print this.
Yes, now you have to print them out with a sentence. Let's see.
Okay. Still showing. My name is.
So there should be a comma after the comma should be after the quotation. Comma name. So the same thing with the other lines. End with the quotation, then you do comma. Go and remove the other quotation that's outside there. When you're done, when you write, save it so that I can see if there'll be any error. Save it first.
I've seen this red yesterday. I don't know why.
I don't think there's an issue. It run the code. Let's see if we give you anything. It's fine, right? But but are you seeing there's something there I've not done this and like I mean, are you seeing the way it's coming out? But you're expecting it to come line by
The,
line, right?
mm-hmm.
So check, go to your code and check. Check your Queen's line. Check you write Queen's line. Are you seeing Queen's? You're seeing Queen's, not Queen's line.
Oh, yeah, yeah, yeah.
So I actually like the fact you have made that error. That tells you that there's another keyword or another function in Rust that also allows you to print. But you see that you
It,
can
do-
see
it,
the difference between it and print line.
mm-hmm.
That's why you understand why now we have that L and other line in print line to show that it prints in a line.
Mm-hmm.
Cargo go and not run cargo.
Wow.
Okay, that's it. Well done.
This that means this dot here was not necessary.
Yes, that was unnecessary.
Yes.
All right.
Man, my
All right, Azebo. So you take out time to practice more tomorrow. Can look for more exercises on this. and then we'll continue on Thursday.
Okay. Okay, sir. Have a
Yeah.
nice evening.
All right, the better one for you. Good night.
Mm.